I'm at Mobile World Congress. I'm here with Rima Qureshi from Verizon. Rima, nice for you to join me today.
Thank you.
Good to be back at an actual physical
Absolutely.
event.
Feels great.
So, I mean, I've just been given a demo of your some of the work you're doing in advanced 5G and robotics and bringing into things like mobile edge computing into play. It's quite a new area really for operators to go into, isn't it? I mean, we're starting to see some of these applications coming into play more at the moment, but can you tell us a little bit about your positioning in that market and how that business is developing at the moment?
We are in the process of launching. Basically everything that you've seen in the demo is real product either already launched or in the process of being launched. So later this year there's going to be a thin client robotics solution. So why robotics? For us, the new business incubation group, their objective is really to look at what are the technologies that will truly be transformed or industries that will be truly transformed as a result of 5G and mobile edge compute. So we really want to look at things that will have an exponential or an order of magnitude improvement in performance, in whichever aspects are most important in that industry. And the robotics use case is, of course, you've got robotics today, but everyone has their own siloed ecosystem, which means that you are stuck with whichever manufacturer that you are using. And more, you've got multi-purpose or multi-use use cases, say within a factory or something. You've got humans, you've got robots, maybe you've got robots from more than one manufacturer, or you would like to have robots from more than one manufacturer, but they don't talk together, they don't work together. So our objective with mobile edge compute is to take the operating system or the brains, if you will, out of the robot and put it into the network. And we are able to demonstrate, which you can see with the robot inside, is the latency is so good that it can sense the movement of another thing or another human, or human I should say, and move out of its way, and it can do that dynamically as a result of the fact that it keeps track of everything that it's around, and it has the latency to be able to respond quickly enough.
And latency is often talked about with 5G, but this is just something that we'd really struggle to do with older technologies,
right,
and without those sorts of benefits that it brings. I mean, how are you? Does it involve a lot of re-architecting of the network? We talk about mobile edge computing and shortening that distance, I guess, between
No, actually, no. I mean, we are deploying mobile edge compute. So we have a private MEC and a public MEC. So the public mobile edge compute is available for developers to develop use cases. And the use cases that we have, for example, on robotics, can work in a private MEC installation as well as a public MEC installation, which allows developers to come in and develop additional capabilities beyond what we have done. And it doesn't really require any re-architecting of the network. If you are wanting a private MEC solution, obviously you need to deploy that within your industry, your factory, whatever. But if it is a public MEC solution, we've got, I believe, 17 different installations today in the US. And with the 5G Future Forum, whatever use cases and solutions we are developing in the US for deployment in the US, can be deployed with our 5G Future Forum partners, so Rogers, America Mobile, Telstra, Vodafone, so a multinational corporation that wants to have all of their factories equipped with the capabilities that we are able to demonstrate here should be able to use that in other locations and other geographies. So we take that software, we take that overall stack of the network, the compute, and the solution, the software as a service solution on top, as well as the robotics that we've changed, and we can deploy that. Another interesting fact is the robots, once you thin them out, they become cheaper and lighter. So we have seen up to 30% reduction in cost and in weight, and in some cases, depending on the type of robot, it could be up to 75%. Now the difference is really what types of things need to remain in the robot. So in there, you've got what we call the robot dog, which is the four-legged robot. That requires a lot more mechanics, if you will, on the device itself to be able to control movement, which means that you may have less savings in terms of what you can actually take off and put into the network. But a wheeled robot, you can take a lot more of it off and you can put it into the network. But then with the mech, you can get them talking to each. I have to be careful because I start beginning to think of them as individuals almost, and they have names, and they feel like they have human characteristics, but
when
they
you
are
have
still
robot
machines.
dogs, then
yes, exactly.
yeah.
Exactly.
How is the robot dog used? I mean, is that something that people are sort of using to provide some kind of service? Or?
Yeah, we have a security use case, which we are in the process of deploying commercially. So. The robot dogs are very useful for perimeter monitoring. So think about a campus, and you've got a car sitting on the lot for 24 hours, and you don't want a human to go out there and maybe potentially come across, a package that you don't want them to, a bomb or something. Yeah. So you can, through your computer vision system, tell the robot that they need to do a perimeter scan, and with the digital twin technology that we've developed, the robot dog is able to determine what kind of car it is, because it creates the twin at the same time as it's doing the scan around, as it's walking around. And then with the digital twin, it can understand what kind of car it is or what kind of truck, and which are the areas it needs to look into. So where should it look in the bed if it is a pickup, and obviously look underneath, and then look inside the vehicle, and then report back. And all of this can be done between the computer vision and monitoring solutions and the robotics dogs without ever having to involve any humans. Because today, yes, you can say all of these solutions exist, but they're, again, silos. They don't work together. And what we are able to do is to make sure that we create that software that allows all of this to work together. And we create that as a platform, and then we're able to take away or add whatever a particular industrial use case may need. My only requirement to them is it has to be on 5G, and it has to be better on mobile edge compute and 5G, and it has to be something that we can commercialize as quickly as possible. We don't want to demonstrate tech. We want to have solutions that enterprises, industries, and eventually consumers can buy as soon as possible.
Right. I mean, maybe just to finish and changing the subject quite dramatically, but you're involved in the ministerial program here. Can you talk a little bit about what you're doing there exactly?
I'm deputy chair of the Edison Alliance, which is with the World Economic Forum, and the Edison Alliance is focused on digital inclusion. So we've got champions from governments, private companies, and the objective is really to address some of the things that became very obvious during the pandemic, is that we need to ensure that we've got the same solutions for connectivity across the board for everyone. And the objective with the Edison Alliance is to impact and improve 1 billion lives. And we focus on the three things that we all needed during the pandemic: support for education, support for health, and finance for banking and so on. The things that we really did at home and we needed to make sure that everybody had access to. So Verizon is the chair, so Hans is the chair, and we've got the likes of Dell, MasterCard, we have the World Economic Forum, you've got a whole bunch of public-private agencies and countries that are actually now joining up to be flagship countries, making commitments to help us reach that overall goal. And we're reporting the results as we go. We have reached more than 1/3 of our target already, and this is being measured and this is being quantified, so this is not just a target we put up and not follow up. So that's what we were talking about.
Great. Okay, well, thanks very much for joining me, Rima.
Thank you.